Okay, let us start our lecture with this question, which says find the number of different 8-letter arrangements so that can be made from the letters of the word daughter so that all vowels occur together. So the first part is that all vowels should be together. To do these kind of questions, this is a new concept, okay? So to do these questions where some of the objects have to be together, so what I'll do is I'll put these objects together, or in this case these vowels together, A, U and E. These are the vowels A, U and E. So what I'll do is I'll tie them into one unit, right? So I'll tie them and treat them as one unit. And what are the rest of the letters? D, G, H, T and R. Now this was an 8-letter arrangement, but I'll treat them 1, 2, 3, 4, 5, 6 as 6 letters. So in how many ways can I arrange these 6 letters? 6 factorial ways, right? But now I've treated this as one unit. Now these 3 vowels can arrange in 3 factorial ways among themselves. They will be together even then, but they can arrange among themselves in 3 factorial ways. So I'll have to multiply this with 3 factorial. Okay. If this condition was not given, then the arrangements would have been 8 factorial, right? But now that these have to be together, so what I've done is I've tied them into one unit and treated them as one unit. So rest of the units, there were 5 other letters. So total 6 letters can be arranged in 6 factorial ways. Now these 3 can be arranged among themselves. For example, this is one of the arrangements. Another arrangement can be AEU. Even then these are together, right? Another can be EAU. So these will give me different words, right? This is a different word, this is a different word, and then there will be total number of 6 factorial into 3 factorial words that can be formed given these conditions. Now the second part is all vowels do not occur together. So we have studied about bijection rule, that if I want to calculate the favorable cases, what I can do is I can subtract the unfavorable from the total. So all vowels do not occur together means I can subtract these number of arrangements when the vowels, all vowels are together from the total arrangements. That would have been 8 factorial. So this will be second part, the answer to second part will be 8 factorial minus 6 factorial into 3 factorial. Okay, so total minus the number of arrangements when these vowels are together. So what is this number? This is 720 into 6 and it will be equal to 0, 2, 4, 3, 2, 0, right? And what will be this one? 6 factorial I'll take as common, 8 into 7 here, and then what is this? 3 factorial, that is 6. So this is 56, this is 6, so it is 50. 6 factorial into 50, that means 720 into 50, which is 3600. Now in how many ways can 4 red, 3 yellow, 2 green discs be arranged in a row if the discs of the same color are indistinguishable? So we are dealing with the case where some are alike, right? Arrangement of objects where some objects are alike, some other objects are of some other kind, right? So what will be the total number of arrangements? 4, 3, 7 and 2, 9. So total 9 discs are there. So 9 factorial arrangements would have been there if all of them were different. But now 4 are red, which are indistinguishable or alike. So I'll divide it with 4 factorial. 3 yellow, so I'll divide it with 3 factorial. 2 green, so I'll divide it with 2 factorial. This will give me the total number of arrangements where as per the given question. Now I want you to calculate this yourself. Find the number of arrangements of the letters of the word independence. Okay, in how many of these arrangements? So first of all, let us find total number of arrangements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12 letters are there. So 12 factorial divided by. Now I'll see if some are alike or not. I is present only one time. N is here, and then again here, and then again here. So I have 3 n's. So I'll divide it by 3 factorial because of the presence of 3 n's. Now let us look at D. D is present here, D is present here. D is present 2 times, 2 D's are present. So I'll divide this by 2 factorial because of the presence of 2 D's, right? What else? E, 1, 2, 3, 4. So I have got 4 E's, right? So I'll divide by 4 factorial here. And then if I've got something else, P is present only once, C is present only once. So yes, this will be the total number of arrangements of the word, of the letters of the word independence. Okay, I have divided with 3 factorial into 2 factorial into 4 factorial because 3 were alike of one kind, that is n, 2 were alike of other kind, that is d's, 4 were alike of some other kind, that were e's. So this is total number of arrangements. Now I've got some specific question. In how many arrangements do the words start with P? So what I'll do here is I'll start the word with P. So I'm fixing my first position with P. Okay, so the first place is fixed. Now what are the total number of letters that I have to use? I have to use total 12 letters are there, right? Total 12 letters are there, out of which P is fixed at first place, right? Now P is fixed at first place, so I'll have to arrange rest of the 11 places. Okay, so what will be the total number of arrangements? 11 factorial. But in these 11 places, I see that 3 n's are together, 3 n's are alike, and 2 are alike of other kind, that is d's, and 4 are alike, that are e's. So I'll divide it with 3 factorial into 2 factorial into 4 factorial. This will be my answer when the word start with P. So I'll fix this position P and make the arrangements in rest of the 11 places using the letters of the word independence here. Let us look at the second part. So what I'll do is, okay, let me make some space here, so we will do it here itself. So do all the vowels always occur together, right? So I have to make some arrangements when all the vowels occur together. What are the vowels? I, E, E, E and E. So there are 1, 2, 3, 4 E's and 1 I. So these are the vowels present, and all of these should be together. So I'll treat them as one unit. E, 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 E and I. Let it be one unit, right? And rest 7 letters be, I'll write rest of the letters here. N, D, P, or what you can do is, rather than writing them, I can simply solve the question directly. Let me now write it when I've started. N, D, P, N, D, N, C. So now I'll treat it as one unit, rest 7 as different 7 units. So I have total 8 units, so total 8 factorial arrangement should be there. But now see, N, N, N is present 3 times, so I'll divide it by 3 factorial. D is present 2 times, so I'll divide it by 2 factorial, and P and C are present only once. Now these are the total number of arrangements when I'm treating this as one unit. Now among this unit itself, these will be arranged in how many ways? I'll have to multiply this result with that. So these can be arranged in 5 factorial divided by 1, 2, 3, 4 factorial. So this is the total number of words or total number of arrangements of the letters of the word independence when all vowels occur together. Do the vowels never occur together? So what I'll do is I'll subtract it from the total that we calculated for the this part. In how many of these arrangements we found the total number of arrangements, right? So we will subtract it from the total number of arrangements. Do the word begin with I and end in P? So in this, what I'll do is I'll start the word, I'll fix the first position and the last position. Out of these 10 intermediate positions, I'll arrange these positions, letters in these positions as 10 factorial, but then I'll have to divide it by how many E's were there? 4. So 4 factorial. How many D's? 1, 2. So 2 factorial. And what else? I have 3n. 1, 2, 3. So I'll divide it by 3 factorial. This is the total number of arrangements of the word when I have got I at the first position and P at the last position. Okay. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? So total number of arrangements will be, how many digits do you have? 9, right? So 9p3 arrangements will be there. So these will be 3-digit numbers that can be formed if no digit is repeated. So what will be this number? 9 into 8 into 7, which will be 72 into 7. So this will be 504. 3-digit numbers will be there. Okay. And if you want to calculate it using fundamental principle of counting, so you have to make 3-digit numbers. So you have to fill 3 places, and you have got 9 digits. So first place can be filled in 9 ways, second in 8, third in 7, and by fundamental principle of counting, this is the total number of ways. How many 4-digit numbers are there with no digit repeated? So when I say how many 4-digit numbers are there, I know the digits are from 0 to 9, right? So I've got only 10 digits out of which I form my numbers. So 4-digit number, how many 4-digit numbers will be there? First place I know can be filled in 9 ways. Why not 10? Because 0 cannot be there at the first place. So first place can be filled in 9 ways. Second place can be filled in 9 ways. Because I have used one of the digits here, so rest 9, any of the rest of 9 can be used here at the second place. And here I can use any of the 8, and here I have got 7 options, right? I have got 10 digits, out of which 0 cannot be used here, right? So I have only 9 options to use for this place, for the first place. And now for the second place, I cannot use the digit I used here, but I can use 0 now. So I still have 9 digits left to use here. Once I filled this place, now 2 places are filled, so I am left with 8 digits. And when 3 places are filled, I am left with 7 digits. So this will be the total number of ways. That is 81 into 56. So you can calculate it yourself. These will be the 4-digit numbers. How many 3-digit even numbers can be made using the digits if no digit is being repeated? Now I need to make 3-digit number, and it should be an even number. So for this place, I have only 1, 2, 3 options. So I have 3 ways to fill this place, the units place. Okay, and no digit is to be repeated. So once I have filled this place, I am left with, how many digits are these? These are 6 digits, right? 1, 2, 3, 4, 5, 6 digits. So out of these, if I have used 1 digit here, I am left with 5 digits. So I can fill this place with any of the 5 digits, and I can fill this place any of the 4 digits. Total 6 digits are there, out of which this place can be filled only with even digits, that is 2, 4 or 6. So I have got 3 ways to fill this place. Now that I have filled this place with any of 2, 4 or 6, I will be left with 5 digits, right? So out of those 5 digits, I can fill any one of them here, and now I am left with 4 digits, so this place can be filled with in 4 ways. So total number of ways are 4 into 5 into 3, that is 60. So 63 digit even numbers will be made out of these digits if no digit is repeated. Now you need not be confused that first I filled this place. This was necessary because I want only even numbers. So it is important that I fill this place first in this question. Okay. Now after that I can fill this place or this place. That won't matter because 5 into 4 or 4 into 5 will give me 20. Find the number of 4-digit numbers that can be formed using the digits 1 to 5 if no digit is repeated. How many of these will be even? Okay, so I am looking for 4-digit numbers using these digits. So I've got 5 digits. How many 4-digit numbers can be formed? 5p4, right, which is 5 into 4 into 3 into 2, right? This is 20, this is 6. So 120 total 4-digit numbers can be formed where no digit is being repeated. Okay, how many of these will be even? So for even numbers, this place can be filled in only 2 ways, right? Now once I have filled this place can be filled in 4 ways because total 5 digits are there. One of the digits I have placed here, so this place can be filled in 4 ways, this place can be filled in 3 ways, this in 2 ways, and this in 2 ways. So total number of options are these 48 ways. These will be even digits. How many of these will be even? 48 will be even. And how many will be odd? 120 minus 48, that is 72, will be odd numbers. Form a committee of 8 persons. In how many ways can we choose a chairman and vice chairman, assuming one person cannot hold more than one position? Okay, so out of 8 persons, we have to select a chairman and a vice chairman, right? See, the question is, there are 8 persons, okay? Now I need to fill 2 places. One is meant for chairman and one is meant for vice chairman. So out of these 8 persons, 2 persons will be there who will fill these 2 places. So what the question means is that I need to arrange 2 persons out of these 8 persons here, right? So the answer is 8p2, that is 8 into 7, which is 56, right? So it is not that you have to choose these, they can be arranged in these 2 positions. One can be here, another can be here, or this can be here or here. Okay, find n if, so n minus 1 p3 divided by n p4 is equal to 1 by 9. This is the question. So let me simplify it a little bit. N minus 1, n minus 2, n minus 3 divided by n, n minus 1, n minus 2, n minus 3, and it is equal to 1 upon 9. So if you see, these can be cancelled and n is equal to 9. Now we need to check whether this is a valid result as per our question or not. So if I place n here, n minus 1 p3, so it is a valid expression because this will be 8 p3, right? So this number here should be greater than this, right? Okay, greater than or equal to. So here also it is okay. So n equal to 9 is a valid answer. Okay. Find R if first part is 5pr. 5pr, that means 5 factorial by 5 minus r factorial is equal to twice of 6 factorial by 6 minus r minus 1, that is 6 minus r plus 1 factorial, right? This is 6 minus r minus 1, which is nothing but this. So the left hand side is 5 factorial by 5 minus r factorial, and on the right hand side I'll have 2 into 6 factorial divided by 7 minus r factorial. 7 minus r factorial. Okay. Alright. So now let me rewrite the right hand side as, let me write it here itself. 2 into, this I can write as 6 into 5 factorial, right, divided by 7 minus r factorial can be written as 7 minus r, 7 minus r minus 1, 7 minus r minus 2, 7 minus r minus 3 factorial, or this much would have been enough. 7 minus r, 7 minus r minus 1, this is 5 minus r, so yes, this I don't have to write this, so factorial here. Why am I doing this? You'll just come to know. 5 factorial by 5 minus r factorial on the left hand side, and on the right hand side I'll write this expression, which is 2 into 6 into 5 factorial divided by this. This is 7 minus r into, this is 7 minus r minus 1, so it is 6 minus r. Now look at this. This is what? This is 5 minus r factorial. Now I can cancel these, right? So and 5 factorial can be cancelled. So I am left with a quadratic expression, which is 7 minus r into 6 minus r equals 12. I have to solve this to find my answer. So let's solve this quadratic expression. 7 minus r into 6 minus r. It is 42 minus 6r minus 7r plus r squared equals 12. So what is the quadratic that I have? R squared. This is minus 13r. And 42 minus 12 is plus 30. So it is r squared minus 10r minus 3r plus 30. You can write it as r minus 10 into r minus 3 equals 0. So r can be either 10 or 3. I just need to validate these answers with the original question. So r, 10 and 3. These are two options. R cannot be 10 because if you see the left hand side here, 5p10 is not a valid expression because I cannot take out 10 from 5, right? So this has to be less than or equal to this. R has to be less than or equal to n. So the only option that I have is 3. R can be 3. And it is very well valid for the left hand side as well as for the right hand side. Let us solve the second part now. Okay, 5pr, that means 5 factorial by 5 minus r factorial is equal to 6pr minus 1, that is 6 factorial divided by 6 minus r minus 1 factorial. So the left hand side is 5 factorial by 5 minus r factorial, and right hand side can be rewritten as 6 into 5 factorial in the numerator, and denominator, if you see, is this minus and this minus will become plus. So this is 7 minus r factorial. So I can write this as 7 minus r into 7 minus r minus 1, that is 6 minus r, then 7 minus r minus 2, that is 5 minus r factorial. Now I will cancel this and this, 5 factorial from here and from here. So this is a similar question, right? This is the quadratic that you need to solve now, which is 42 minus 6r minus 7r plus r squared equal to 6, and the quadratic is 6r square minus 13r. 42 minus 6, that is 36 plus 36, right, equals 0. 9 and 4, so I can write it as r square minus 9r minus 4r plus 36 equal to 0. So r can be either 9 or 4. So out of these, 4 is the only acceptable answer because 5p9 is not a valid option. 5p4 is valid, 6p3 is a valid answer. So yes, r is equal to 4 for the second part, this part. how many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once. So I have to use each letter exactly once and form words with or without meaning. So let us see. 1, 2, 3, 4, 5, 6, 7, 8. I have got total 8 letters, right? And all of these are different, right? E, Q, U, A, T, I, O, N. So all of these are different. So all 8 factorial arrangements can be there. 8 factorial words can be formed using all the letters, right? Because I have to use all the letters. So this question is nothing but I've got 8 different objects and I have to arrange them in a row. So 8 factorial ways these can be arranged. Okay. Alright. So if you want to write the exact answer, what you can do is 7 factorial into 8. What was 7 factorial? 5040 into 8. So this is 320 and 40,000. So 40320. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated, if 4 letters are used at a time? Okay. So out of these 4 are used. 1, 2, 3, 4, 5, 6. 6 letters are there and I have to use 4 at a time. So 6p4 letters can be formed with or without meaning, right? And what is 6p4? 6 into 5 into 4 into 3, which is 24 into 3, 72 into 5, 360. What about the second part? All letters are used at a time. So these are 6 letters and total number of arrangements will be 6 factorial, which is 720. All letters are used, but first letter is a vowel. So now I have to fix first letter 4, 5, 6. So this first letter is fixed because this is a vowel. So I'll fix this and I've got only 2 options to use from, O and A. These are the vowels, right? So the first place can be filled only in 2 ways, right? And now these are 2 ways I can fill the first place. Once I fill the first place, I'll be left with 5 digits, 5 letters. These are 6 letters total, right? Out of them, there were 2 vowels, out of which I have filled one here. So I am left with 5 letters now. So this place can be filled in 5 ways, this in 4 ways, this in 3 ways, 2 ways, only 1 way. So this is the answer. 5 factorial, that is 120 into 2. 240 ways I can form if all letters are used but first letter is a vowel. I hope you got the idea.